Okay, so for these first questions, we're going to do f of g of x. So that's f of g of x, or f of, replace the g of x with 5x plus 2. And now this 5x plus 2 gets plugged into the f function. So this becomes 5x plus 2 in place of the x squared minus 5. Distribute that out. 25x squared plus 10x, and 10x is 20x, plus 4 minus 5, so 25x squared plus 20x, about minus 1. G of f of x, very similar. It'll just be g of f of x. F of x gets replaced with x squared minus 5. So this x squared minus 5 gets plugged right there into the g function. So this becomes 5 times x squared minus 5 in place of the x plus 2. 5x squared minus 25 plus 10. 5x squared, about minus 15. When I want to plug in a 3, I don't have to plug it into each one. I could do f of g of 3, but I already have a new function up here, so I could plug this 3 into my composite function. So that would be 25 times 3 squared plus 20 times 3 minus 1. So how about 25 times 9? Should be 225 plus 60 minus 1. 285 minus 1, about 284. G of f of 0, I don't have to plug in. I could do g of f of 0, but I don't have to. I have this new function where I could just plug in the 0 there, so it becomes 5 times 0 squared minus 15. 0 minus 15, just negative 15. F of g of x, just to kick it up a notch again, so f of g of x, f of, start on the inside, 5x minus 5. Now this 5x minus 5 gets plugged into the f function, unfortunately in place of both of these x's. So 4 times 5x minus 5 squared, 5 times 5x minus 5 plus 3. So let's see, 4 times 25x squared minus 50x plus 25 plus 25x minus 25 plus 3, 100x squared, 200x plus 100 plus 25x, looks like that's minus 22. So 100x squared, 200 plus 25, how about minus 175x plus 78. G of x, g of x, g of 5x minus 5. This 5x minus 5 gets plugged back into itself, into the g function. So it becomes 5 times. In place of the x, we put 5x minus 5, minus 5, 25x minus 25 minus 5, 25x minus 30. F of g of x is f of x minus 4. X minus 4 gets plugged into the f function, so 6 over x minus 4 squared. I would distribute that out. So we would get 6 over x squared minus 8x plus 16. F of g of 3, I would plug a 3 into not the original functions, but into this. I could do f of g of 3, or I can just plug the 3 into this function. So 6 over 3 squared minus 8 times 3 plus 16. 6 over 9, what is that, 8, 16, 24. 6 over 1, or just 6. What would f of g of 4 be? Well, I could plug in a 4. 6 over 4 squared is 16. Minus 8 times 4 is 32. Plus 16. We get 6 over 32 minus 32. 6 over 0. What is that? Undefined. Because we put a 0 in the denominator the minute we put a 4. Even though the 4 would not have been a restriction for the g, because we put it in the denominator, it becomes a restriction on our composite function. 1 to 1, I'm looking for 2 tests. Vertical lines, each one cross 1. Horizontal line, each one crosses once. So yes, this is 1 to 1. This one, vertical line, no problems there. Horizontal line, we got a problem. This crosses 3 times, which means even though this is a function, it is not a 1 to 1 function. This one, vertical lines, no problems. Horizontal lines, no problems. Even though it starts to become horizontal, it never quite exactly becomes horizontal. So this passes the test. It is 1 to 1. Find a formula for the inverse. Step 1 was we switch x and y. F of x is the same thing as y. Switching them. Solve for y. Add 4. Undo multiplying by 1/7 by multiplying both sides by, how about 7? Y is equal to. You don't have to distribute this. If you did, I wouldn't mark you off, but we'd leave it just like that. Do make sure you write your answer as the inverse function of x is equal to 7 times x plus 4. This one, switching x and y. Solving it. Square rooting it. Y is equal to plus or minus. Technically, I could give you full credit if you were to do this. But, technically, I could also give you full credit if you just say that this is not a 1-to-1 function. So therefore, there is no inverse function. The issue is that our first graph was basically a parabola with a y-intercept of -7. So if it's not 1-to-1, and I go to do the inverse, this inverse would also not be 1-to-1. So it's not an inverse function. If you switch the x and the y and you solve it, I probably wouldn't mark you off for that in this class. But since I was really looking for an inverse function, this would be the correct answer. Each of these has 5/3 x minus 2 graphed as the dotted line. So what I would do is I would switch the points x and y. So I would take the points, it looks like 0, 2, and let's see if that's another point. Looks like 6, -11. Maybe I'm wrong on that one. Oh, it's a solid line. That's my mistake. So, geez. So how about 3 and up 3. Let's take those 2 points and switch them. 0, negative 2. If I switch them, becomes negative 2, 0. Does this one cross at negative 2, 0? Does not. It's not my answer. Does this one cross at negative 2, 0? It does. I'm okay with that one. Does this one cross at negative 2, 0? Does not. Does this one cross at negative 2, 0? Does not. I'm thinking the answer is C. Just to double check, our other point we found was, what, 3, 3? If I switch that, my other graph should cross at 3, 3. 3, 3. They both cross at that point. And last, we said to check, they should be symmetric across a line, y equals x, and they are. So our correct answer is C. Find a couple points, switch them. This is probably a lot more similar to what you would see on the test. Square root of x minus 4 or x plus 4. The solid line, I see 2 points. I see 0, negative 4. And I see about, or negative 4, 0, sorry, and 0, 2. Switch those points. Negative 4, 0, I should see a point at 0, negative 4. Alright, my goodness, I'm messing this all up. Okay. Negative 4, 0. I should see a point at 0, negative 4. I do not. I should see a point at 0, negative 4. I do not. I should see a point at 0, negative 4. I do not. I should see a point at 0, negative 4. I do. I'm looking good on this one. 0, 2 becomes 2, 0. Do make sure that you can sketch it. So once you switch the points, you sketch something that is symmetric to the line y equals x. This one was rocketing to the right. You need to draw the one that's rocketing upward. Check that it is an inverse. So we plug one function into the other function. So I'm going to check on the inverse, or on the inside. That is 2x minus 5. So if I plug that into the f function, I get, in place of the x, plus 5 all over 2. We start combining like terms. 2x minus 5 plus 5 just becomes 2x over 2. The 2's cancel, leaving us with just x. This is an inverse function. This is correct. On the next one, same process. I should be able to do f of, and it should give me x. Let's see. 8x minus 9. The 9's do not cancel. So this is not correct. This is not the inverse function. If it was correct, the inverse function should give us just an x. Second one does not. So therefore it is not the inverse function. Graph 2 to the x, I encourage you to graph 3 points. Negative 1, 2 to the negative 1 is 1 half. 2 to the 0 is 1, 2 to the first is 2. 1 half, 1, 2. That's enough for me to get a sketch. This side the graph rockets upward. This side gets closer and closer to 0. As an asymptote there, y equals 0. This one, the complicated part is that it's been shifted. So my first step is to ignore the shifting and just graph. 3 points I need. 3 to the negative 1, 3 to the 0, and 3 to the 1. This is not my final graph. This is not my final answer. It needs to be shifted. Shifted how? Well, that plus 3 means we will shift 3 up. Every point gets moved up 1, 2, 3. Every point gets moved up 1, 2, 3. Every point gets moved up 1, 2, 3. So my final graph looks just like the parent. Sorry about that. Shifted up 3. Do be careful because the asymptote, which was down here, also got shifted up 3. So make sure that graph does not go below that 3. Next two follow the same process, so I'm basically graphing the same 3 points. -1, 0, and 1. -1, 1/5 to the -1 gives me 5, to the 0 gives me 1, here gives me 1/5. What that does is it basically switches the overall look of the graph. Now it gets closer to 0 to the right, and it shoots up rockward to the left. Like a rocket, sorry, to the left. This one, first step is I ignore that shifting. So I'm just going to graph. Same 3 points. So that negative 1/2 to the -1 is 2, to the 0 is 1, 1 is 1/2. The difference here this time is that this is not my final graph. I need to shift it. This has an H opposite of 3, so it shifts it 3 to the right. Each of these points gets shifted. 3 to the right, 3 to the right, 3 to the right. So this is my final graph. Notice this time it doesn't shift up or down, so the asymptote doesn't move. For the next several questions, I encourage you to learn how to read logarithms with meaning. So this literally says, right, 4 to what exponent makes 1/4? Well, that would be -1. 8 to what exponent makes 64? This doesn't have a base, so you have to know that's 10 to what exponent makes 10. And this is an inverse function. The idea that logs, the inverse of a log, is an exponent with the same base. So since these are inverses, they can cancel each other out, which we'll use later on, leaving us with just 10. This is similar. We're going to rewrite them in exponential form. So our base is 4 to the t is equal to 64. So we're saying 4 to what power makes 64? Well, I believe that's 4 to the third. So t would equal 3. This says 5 to what power makes 25? 5 to what power makes 25? Well, I believe that x would be 2, 5 squared. This one has no base. It says 10 to what power would give me 1 over 100? Well, that would be 10 to the -2. And last, base to the exponent is equal to the result. This one's not solvable, so that's it on that one. Okay, so be able to rewrite these and be able to read them with meaning, and the logarithm questions should be very, very easy. So rewriting these into log form, what we do is we do log of the base, and here goes the result, is equal to the exponent. 2 to the third is 8. Log base of the result equals the exponent. Same on this one, so log of the base. The result is 1 over 64 is equal to the exponent. Log of the base, log of base 49 of the result, 7 equals 1/2. None of these we're solving, we're just rewriting them. Log of the base, the result is 12 is equal to the exponent z. We're rewriting these in exponential form and solving them. So 5 to the exponent 4 is equal to x. 5 to the fourth is 625. This becomes 5 to the -4 equals x. That would be 1 over 625. This becomes what? 2 to what exponent makes 1/8? That would be -3. This becomes x to the exponent third is equal to 8. What to the third power is 8? X would be 2. So rewrite them and then solve them. Technically, if these ones up here were a little confusing, I could make this 2 and 1/8 into the same exponent, but I'm hoping we can figure that one out logically. Now we're going to be expanding using our rules. It's the same rules of exponents, so multiplication expands into 2 logs, same base, and multiplication turns into addition, and then we put the 2 terms. This has an exponent, so the exponent turns into multiplication, so 8 times log base b of t. This one, division. Division turns into subtraction, so it'll expand, into 2 logs, the positive one on top and the negative one on the bottom, because I didn't need all that space. Now this one's a bit of a mess, so I see 1, 2, 3, 4 terms that are multiplying, so this will expand into 4 separate logs, all freaking base a. Our first term is 7, second term is x squared, third term is y, and fourth term is z to the third. So all of them were multiplying, so all of them are positive. The only other thing we have to do is bring that exponent, any exponents to the front. So log base a of 7 plus 2 log base a of x plus log base a of y plus 3 log base a of z. And that would be finalized. This last one I see 4 terms, so 4 logs, all base b. The 2 on the top are positive, m to the 5th, p to the 3rd. The 2 in the denominator are both negative, n to the 8th, b to the 7th. Move all the exponents to the front. 5 log base b of m plus 3 log base b of p minus 8 log base b of n minus 7. Why is that one done? Well, because I'm left with what? Log base b of b, which goes away. So just minus 7. Do make sure you simplify those when you can. Not a huge issue, but something that will pop up, so please be careful with that. Condensing, the 2 positives, they condense into 1 log. Positives are on top. The negatives divide on the bottom. This one, before we can condense it, we have to bring these up. So log of t to the 8th minus log of t to the 4th. Now they can condense into a single log, t to the 8th on the top, t to the 4th on the bottom. Well, that's interesting. We should simplify that. This is just log of t to the 4th. What's interesting about that is that these were like terms. I could have actually subtracted them. 8 log t minus 4 log t is just 4 log t. I could have just combined like terms and gone straight to that and then brought the 4 up. But if I use the rules, I get the same answer either way. Bringing the number up, I have log of a to the 9th, log of b squared, minus log c. Everything positive goes to the top. So log of a to the 9th times b squared over the c. And last but not least here, we bring up log base 3 of x to the 1/3, log base 3 of y to the 6th, minus log base 3 of x to the 3rd. So we can now bring these together. The positives both go on the top. So log base 3 x to the 1/3, y to the 6th, all over x to the 3rd. I'm fine with that. You could try to rationalize this and mess with it. I would also accept that 1/3 as the 3rd root of x. If you wanted to put it like that, times y to the 6th over, I would accept that as well. But either way, just make sure that you know how to condense them. Move the exponent first, and then bring them together. Adding turns into multiplying, subtracting turns into division. At this point, we're going to be using our calculator. So obviously, you should be able to type these into your calculator. And then what we're going to do is we also need to make sure we can check our answers. So let's go ahead and start with log of 132. So if I do, and obviously your button's probably going to be different than mine, and apparently I'm not even in the right spot. So there we go. That's escape there. Let's see. Calculator, log of 132, and I'll leave that blank. And there's my decimal, so 2.12057. And we can check that because our base is 10. So 10 to the 2.12 should equal 132. 10 raised to the answer should be 132. So just encouraging you, you can check these as you go. 39, log of 0.19 should be pretty small. Let's see. Log of 0.19. How about negative 0.7212? And you can check it. Log base 3 of 10. Now my calculator does log base 3, so that's fine, but if yours doesn't, you have to use the change of base, where it's log of the result divided by log of the base. So I can do that one of two ways. I can do log of 10 divided by log of 3 okay? Or if you have a calculator that does this, you can do log base 3 of 10. And either way, we should get 2.0959. Natural log of 67. So that would be natural log of 67. And remember, I can check this because this is log base e. So I can basically say e, wrong button, e raised to that answer should be, I'm lost, give me a second, natural log of 67. And I can say e to that answer should be 67. So 4.20469. Natural log of 0.995. Negative 0.005. And log base e of 44. I'm not going to use the change of base on that. I could try to do log of 44 divided by log of e, but it's easier just to know log base e is the natural log of 44. Or 3.784. Okay. How are we going to solve these? Well, when I can, I want to make them the same base. So these can be both written as base 3. This is 3 to the 4th. Once we have the bases equal, we can set the exponents equal. So that x equals 5. Same with this one, but 4 and 8, you can't write 8 as base 4, but you can write them both as base 2. Using the power rules, this becomes 4x plus 2 is equal to the other exponent 3. Subtracting, you should get 1, and then dividing, you should get 1/4. This one, 9 and 27, can both be written as base 3. product rule here, or power rule, sorry. 2 and 3x, how about 6x is equal to 6x plus 9. Moving the 6x, we get 0 equals 9. That means this problem has no solution. Six to the x equals 22. Well, to undo that exponent, we log both sides. Remember, the idea of expanding is now that x can come to the front. So I have x times log of 6 is equal to log of 22. Divide both sides by log of 6. Log of 22 divided by log of 6. About 1.725. 12 to the x plus 3. Once again, I'm going to log both sides so that the x plus 3 can travel to the front. I'll have log of 24 on this side. We're going to divide by the log of 12. Log of 24 divided by log of 12 is not 2, so don't do that. They don't cancel like that. If your calculator doesn't handle this, you're going to have to make some decimals and handle this. But now I have that x plus 3 is equal to this mess. And so to solve for x, whatever we get here, we're going to subtract 3. So log of 24 divided by log of 12. Log of 24 divided by log of 12. And then we had a minus 3 after that. So we should have negative 1.721. How do I undo a log? Well, if I undo an exponent with a log, then I undo a log with an exponent. This is log base e, so I'm going to rewrite this as doing an e to the. These cancel. X is equal to e to the third. That's a fine answer. If they wanted the approximation, you would just take e to the third, and you'd write down 20.0855. This one we cannot undo yet. We have to undo this multiplication first, so divide first. So the natural log of x equals negative 3. Undo the natural log by raising both sides as a power of e, so that x is equal to e to the negative third. Feel free to get the decimal if you want on that. How do we undo log of x? Well, this is log base 10, so we use a 10 to the. So our exact answer is 10 to the 2.5. You can get that as a decimal, so 10 to the 2.5. Ten to the 2.5. How about 316.228? Okay. These ones that I circled, all of those are the exact answers. I will be asking for something like that on the test. All of these are approximations. So make sure you can get both. Last but not least, we undo a log base 4. 4 to the, 4 to the. So we're left with 4x minus 8 is equal to 64. Add 8. 4x is equal to 72. Divide by 4. I think we're looking at 18. This one, we cannot undo the log until we condense. So log of x over x plus 2. Then I undo the log base 10 with a 10 to the, 10 to the. So x over x plus 2 is equal to 10. Multiply that up. X is equal to about 10x plus 20. Subtract and divide. At the end, I think we should end up with, how about negative 20 over 9. Last but not least, we will condense these. Log base 9 of, we're going to multiply this, so it's going to end up being x minus 2 times x minus 2 is equal to, I'm going to simplify, log base 9 of 9 is 1. Multiplying this out, log base 9 of x squared minus 4x plus 4. Undo log base 9 by raising both sides as a power of 9. X squared minus 4x plus 4 equals 9. Subtracting the 9, x squared minus 4x minus 5 equals 0. Factoring this, see if I can write over here, yep. How about x minus 5, x plus 1, each one set equal to 0, so that x is equal to 5, and x is equal to positive, or negative 1. In this situation, we cannot have a negative. That would be extraneous. So our answer is just the 5. So that's it. Happy studying. Good luck.